Assalamu alaikum and welcome. This is our presentation for uh, case one of the power system analysis project. In this case, we will perform a load flow analysis using the Powerworld simulator to determine the steady state operation condition for the given power system. Our goal is obtain the bus, line, and transformer input, output data files which help us to understand the system voltage profile, power flow, and losses. So let's get an system overview. First, we have the 7 bus of these systems and 2 generators, 2 transformers, and 5 transmission lines. The generators are connected to the bus 1 and bus 7. And bus 1 is the slack in this is the slacks one, while the load distributed across bus 2 and through bus 2 to bus 6. This system operated at base power of 100 megavolt ampere and base voltage 3.8 kilovolt. The zone of generators G1 are takes into the analysis. This system using the we will analyze as we mentioned with power flow simulator. Before running the simulation, we need to operate system data. So let's take a look for system data. Let's see. So all we have this for bus records. We add the per unit values using the given base quantities, and all these values it's before for the transmission lines before actually for buses before run, and this for transformers controls, which is these values, and this for loads. So let's run our simulator and see what will happen. So run mode and how we are run. Okay. And after run we have to know, and that's our goal actually, to know the values of the systems. Oh, sorry, I have to stop running and get the values. So actually our main to know the bus's value. So let's see. As we see, it's our after run for bus 1. The per unit voltage is actually the same, and bus 2 is 0.932, bus 3 is 0.926, and bus 4, and this is our main our goal actually. And we have to know this our bus 4 magnitude for voltage, and it's 0.9277. So our goal actually in case 2 is to increase this value of voltage by 5%, and that will be discussed in the discussion of the case 2. And that is it. That's all. Thank you.
Assalamu alaikum. My name is Muhammad Saifuddin, and I'll be discussing about the method we decide to use in order to improve the voltage at bus 4 and increase its value by 5%. Simply put, our inductive loads at bus 4 lead to a reduction in our power factor, thus leading in some losses when it comes to our line or our bus voltage. To help improve this, we need to correct our power factor. This can be done by adding a shunt capacitor. The shunt capacitor, as we all know, will help by introducing a negative reactive power that will fight back against our inductive load's reactive power, thus improving the overall efficiency of our system and increasing the overall voltage at bus 4 by about 5%.
Hello, Assalamu alaikum. I'm Muhammad Abdul Saleh Lazim. I'm going to take you through the verification of our method to increase the voltage at bus 4 by 5%. So I have already added the shunt capacitor. All I have to do is enabling or turning on the circuit breaker here. Then we will go to run. We run it. So we can see here that the voltage at bus 4 has increased by 5%. Previously it was 0.97 and now it's previously it was 0.93 and now it's 0.97. We can also see the total voltages and added buses in the module Explorer as it's shown here. So we can see here the voltages at each bus, the new voltages at each bus. We can see here that the targeted bus have been changed to 0.974. Previously it was 0.22 something. So it have increased by nearly 5%. And we can see also the transformer outputs and additionally to the load outputs, as you can see here. Okay, we can see that our method has been successfully verified, and this is the end of our presentation. Thank you very much for your watching. Assalamu alaikum warahmatullah.